Hello guys, welcome to my YouTube channel. Today we are going to do floors, but I want to address something which I did on the previous video regarding risk of collapse, but I explained everything correctly regarding risk of collapse. I've already done everything. I'll just explain what's going on. We're going to start here. We ended with risk of collapse on the last video. This is part 3 in the last video, so I wanted to keep this video short. Last time we did, I have already done the floors. Last time we did risk of collapse. Where is it? Yeah, we ended here. We did the risk of collapse. Yeah, we were separate the size of the trench not exceeding 1.5 millimeters. We do our risk of collapse in categories of 1.5 meters. Yeah, you just use a center line. We're going to use a center line, not your center line, man. The perimeter of the external sides of the trench, and then you multiply by this thing. This thing is very simple. Sometimes they make it seems like it's complicated, where they take those sides, they say they do for one side and they multiply by 2, these sides are equal, and then they do that another. It is a long process. This one is the easiest one. This one is the easiest one. You just take the perimeter of the external trench, and then then we take the perimeter of the internal trench, and then we multiply by the depth. And yeah, let me explain here. Let me go to the drawing so that I can show you. Here, we want to support the sides of the trench. The depth of the trench is 2.4. Here, we're supposed to have a line here going down here to show us this is our trench, and then this is our space. We're going to support the sides of the trench. We're going to use the perimeter of the building. We're going to use the perimeter of the external sides of the sides of the trench. We're going to use this dotted line, the outside one. You see, the whole of it, and then you can get this because you calculated your center line. You just go to your topsoil removal, your waste calculation for center line, and then you don't deduct anything. You just use the perimeter. Let me go to the waste calculation for the center line so that I can show you. We did our waste calculation for the center line. This is our perimeter for the external trench. We don't have to less anything. We just use it as it is. Yeah, so we have this. This is our perimeter, and then the depth. Remember, we're excavating in categories. The first length, and then let me go to the plan so that I can show you. We're going to support the sides of the trench from here up until 1.5. Let me use a marker so that you can see. Let's say we're going to support the sides of the trench from here up until 1.5. Let's say 1.5 is around here. And then also on this side, we're going to support the sides of the trench from the reduced level up until 1.5. It will also be here. They will be equal. And remember, on this side, we are supporting the side of the trench up until 1.5 from natural ground level. So, and then here we are working from reduced level. We will have to subtract the 0.5 of the depth, which is the depth of the topsoil remove, from the 1.5. We're going to get 1.35, and then let me go to the risk of collapse so that I can just explain, and then I will explain the floors. And then floors are also easy. There's nothing hard about this thing. Maybe I will think about editing some videos. Maybe I will do superstructure, or maybe I'll do I'll do what do you call, where we have a building, we have an existing building on our side. We have to demolish the building, or I can also do the alterations, maybe let's say like we want to extend, like, and then we want to demolish part of the building, I'll do that. Here the first part of risk of collapse, we're going to use the external sides. We're going to use 1.5. For the internal sides, we're going to use 1.35 because we had to subtract the topsoil removed, and then we get this one. And then we move to the second part. The second part is obvious. Remember, when you subtract it, when you will be left with the distance from here to here up until here. You're going to subtract the, let's say you're going to take the 2.4, you subtract the width of the thickness of the trench, and then you also subtract the 1.5, and you'll be left with 0.6 meters. And then also on this side, we also have 0.6 meters from here to here, and then we just use the, and then let me explain. What should I explain? The perimeter. I should explain the perimeter of the internal trench. How do we get it? Where is it from? Here is the award, and this is the risk of collapse for the from natural ground level to 1.5 meters deep. And then here we use the external perimeter. Here we use the internal perimeter of the trench, and then we use the depth, is this depth, and then we'll calculate to get our things. We are done. Let me explain the center line of the internal trench. How do you find it? Remember, you did some calculation for big field, and then you calculated the center line for the internal trench, where you were using the internal dimensions of the trench. So since you were using the internal dimensions of the trench, which means you will have a perimeter of the internal side of the trench before you do your adding of corners. Which means our perimeter is here. Our perimeter is 59.88. Just go there and substitute, and then we are done with risk of collapse. And then now we're going to move to floors. So we're going to do floors. We're going to start with hardcore, doing them in order. We're going to start with hardcore. We are done with floors. Okay, man, remember, we're not done with floors. We have to do the brick foundation. This one is obvious. I will not need to explain anything. I'll just explain this part only, the 2.3. For the brick wall, we're going to use the center line that we calculated when we were calculating the center line for the trench. And then let me explain this part only. Remember, our brick wall is not from the surface of the concrete footing to the natural ground level. Our brick wall is our foundation brick wall is from the surface of the concrete footing up until the level of the surface of the concrete surface bed. We're going to end where we start laying our DPC, which is the damp-proof course. Our length is going to be, which means, let's say here we have the natural ground level is here. This is our natural ground level, and then which means we have the dimension from here to here is to calculate the dimension from the surface of the concrete footing up until the natural ground level. You just take the 2.4 meters, you subtract the 0.3 meters, and then remember we also have to add this part from natural ground level, which is this part up until here, which is from here up until the surface of the concrete bed, even up until the surface of the concrete surface bed. Which means the thickness of the sand blending is 50 millimeters, and the thickness of the concrete footing 150 millimeters, and then all those two things will get 200 millimeters, and then we're going to add the 200 millimeters to the 2.1 2.1 meters, which is the length from here to here, which is 2.1 meters. We're going to add 0.2 meters, and then we're going to get 2.3 meters, and then we are done with the brick wall. Just book a dimension to get your answer, and then we move to the side. Now we're going to do our hardcore, our floors. Yeah, first of all, we're going to have our waist calculation. The only thing we have to do here, we have to calculate like the area of the floor. Let me change this. Let me also first erase all and then change this. We'll have to calculate the area of the floor. I can say the area of the TPC, or the area of the concrete surface bed, which is this one. It's from here to here, from here to here, from here to here, from here to here. Yeah, remember we calculated the area of the topsoil removed, which means when we want the area of the floor, we just subtract the horizontal area of the brick, and then we also subtract the horizontal area of the trench. I have a formula. I wrote my formula here. I just write the area of the floor is equal to the area of the topsoil removed, subtract the area of the brick wall, subtract the area of the external trench. We're talking about the horizontal area. And then our topsoil, the area here, it is the area of the topsoil removed. Area of the topsoil removed is this one, and then we less the area of the brick, which is this one. We less the area of the trench. Like for the brick, we have the center line. We have to just multiply with the thickness of the brick, and then we're going to get the area of the brick, which we should deduct from the area of the topsoil. And then here we have the center line for the external trench, which is from when we were calculating when we were doing the waist calculation for there's no need to show that. We did the waist calculation to calculate the center line for the external trench. We're going to use the center line for the external trench is this one, and then we multiply by this one, and then it's equals to this one. We get this one, and then now we have to find the area of the floor. We're going to just take this one and subtract this one and subtract this one, and then we get this thing, which is how much? This is millions. We're talking about 144,496,700, and then yeah, we're done. And then you just remember this thing is in millimeters, and then you will have to convert. Like, let me start here. Like here we had our area of the topsoil removed it was in meters. To convert it to millimeters, I'm sure in the description column we write our dimensions in millimeters. You just have to multiply by a million, because remember, when you compare to 1 meter to millimeters, you multiply by 1,000, and here we are having meter times meter, which means we're going to multiply by 1,000. We're going to multiply by 1,000 times 1,000, which is going to be, it's just like as we are multiplying with a million, and then we get this answer. And then here, this one is also simple. This one for the center line, it was in millimeters, and then we got these things. We get these things, and then we subtract to get the area of the floor. Here is the area of the floor, not area of the floor. And then we're done. We have the area of the floor. When you come to this side, you also have to, you just use the what is this, the area of the floor when you do a hardcore. And then remember, we have to show the hardcore is measured in meters squares. It's from SX13. We fill the underfloor with stones or broken bricks, and then we just take this thing. We'll just take our area, and then we multiply by the thickness. The thickness is this one. Remember, we also have to show this thing is the volume, so we'll have to just multiply by 1, and then we multiply by the thickness. This is our width, and then this is our thickness. The thickness is always the last one. The thickness of the depth of the heart is always the last one, and then you get this one. Let me just underline this so things can be easy. And then now we're going to do sand blending. It's the same thing. You just take this thing. The only thing that is going to change is the depth of the sand blending, and then the depth of the sand blending. Let me just go here so that you can see everything. I talked about the depth of the sand blending when we were doing the brick wall. The depth of the sand blending is 0.05 meters, which is 50 millimeters, and then the depth of the hardcore is 150 millimeters. Compacted backfilling is this one. This is the hardcore. And then let me go back again onto Excel. I'm going back to Excel. We use the 0.05 meters, and then we must be able to get this thing. Then we're done with sand blending, and then now we'll do our DPC. Our DPC is measured in meters squared. You just have to take the area and multiply by 1 to show that it is an area, and then I'll have to underline this. And then we are done with the DPC. Your description, you see it here. Cover the sand blending with 250 micron dpm for waterproofing. And then for the concrete surface bed, now we're doing the concrete surface bed. For the concrete surface bed, you're going to just take the area and multiply by 1 and multiply by the thickness. This is to show that this thing is a volume, and then you get the answer here. And then let me just underline this, and then I will also share the link for you to download the complete taking off for this building. And then there are some things there. Let me, like on my previous video, I didn't show that there's something which I didn't show, that it was a volume. When we do cutaway, like I just used the area. I just wrote the area in our dimension column. Where is it? Where is that part? Cutaway. We were doing cutaway. Yeah, it's here. It starts from here. It starts here. This is cutaway. It starts here. We did the concrete footing, and then also we had to add the foundation brick wall and add the topsoil removed. And then here, remember here this thing is a volume. I'll just have to copy. Let me write these dimensions here. I have to show this is a volume. Just write 2.5. Is this 0.8586 man? It's 86, and then I'll just have to replace this one with 1. It is 1, and then I'll just have to do this. This one, it will be 53. It will be this cell, and then I click enter. Then we're done. Here, just have to move these things to this side, man. This side, so that everything is perfect. Yeah, everything now is perfect. We are done with our taking off is everything, and then I'll do a short video where I explain everything, how to calculate them, because I know some of you, they say my videos are very long, but I will explain everything like in under 20 minutes, everything, because I will not be doing the calculation. I'll be just explaining everything in under 20 minutes. Now I'm done. I'll end this video here, and remember, I'll share this taking off list, then the weekend drawing. You'll find it in the description.